Welcome everyone to our lesson on normals. Okay, so I have already covered the lesson on tangents. I've already covered tangents, so I would recommend that video to you as well. Right, let's start. So given that we have a curve called f of x, all right, so a tangent is the line that cuts the curve at one point. Okay, so a normal is the line that crosses the tangent at right angle. All right, so the normal will meet the tangent at a right angle. So that is what a normal is. So a normal is just a line meeting the tangent at 90 degrees. All right, okay, so the gradient of the tangent, okay, so when a line meets another line at right angle, what it actually means is that the gradient of the tangent times the gradient of the normal should give you -1. And this is a fact, a mathematical fact that you need to know. Right, so like I said, I've already covered the lesson on tangent. Okay, right, so the perpendicular, so a line, okay, that is perpendicular to the tangent at the point A is what we call the normal. Right, I've covered that in the previous slide. So let's say that you are given a point, okay, and there's a line passing through that point. So the dy dx, that's the gradient of the curve at the point x equals 1 is m, right? So if that is what you find, then the equation of the normal is given as y minus y1 is equal to -1 over m into bracket x minus 1. Now, if you have watched the video on tangent, you would see that what we have here is m, okay, is m, and then what we have for normals is -1 over m. Now, I told you that the product of the gradient of tangent and normal should be equal to -1. All right, so if the gradient, which is tangent to the curve, is called m, okay, then the normal, the gradient for the normal should be -1 over m. Why? Because if I have -1 over m and I multiply by m, my answer should be equal to -1, right? Because they meet at right angles. So what you do is that you find your dy dx, okay, the gradient, and then you negate and you reciprocate. That's all. Let's start with an example and see what I'm talking about. Right, so find the equation of the normal to the curve this, okay, at this point. Right, so the first thing that we want to do is to differentiate this curve, and that will give us x squared plus 10x. Right, so let's find the gradient. This is the gradient function, but from the gradient function we can find the gradient at x equals 1. So at x equals 1, dy dx is what? Is 16, right? So now we know that dy dx equals 16. So what else do? We know that the equation of the normal is given as this, right? So all that we need to do is to find our y1, because the question gave us the x value, which was 1, so we need to find a y. So you put the x into the curve, and that gives you -6. So we know y1 to be, it gives us 6. So we know y1 to be 6, we know x1 to be 1. Now the gradient, which is m dy dx, is 16, so we just put it here and we are good to go. So that is what we have, okay? That is what we have. The 16 is the gradient, but remember that it is always -1 over the m, okay, because it is normal. Now you are almost done. You expand and then you simplify. So we expand and then we simplify, and this is what we have. Negative 1 over 16x plus 97 over 16. Let's take another example. So we want to find the equation of the normal to the curve at the point x equals 1. Okay, so we would differentiate this. All right, so this is the curve. Normally I would urge you to set it up this way, okay, so that you can easily differentiate. Now writing 3 over x as 3x raised to the power negative 1 comes from our lesson on indices, okay, from our knowledge of indices we can say this. Right, so let's differentiate. When we differentiate, this is what we get. All right, now we want to find a gradient at x equals 1. I'll repeat this on the next slide for us. So the gradient at x equals 1, what do we get? You just put 1 in place of x, and then the gradient is what? 8. Now we need to also look for the y1. Since we know the x value, let's look for the corresponding y value. We do that by putting the value of x into the curve, and that gives us a y value of 2. So now we know our gradient, we know x1, we know y1. We can find the equation of the normal. So it is of this form, all right? So the y1 is 2, the x1 is 1, and then the gradient is what? Is 8. So we, in place of m, we put 8 there. So that is what we have. Now we are almost done. We would have to expand this bracket, and then we are done. So we expand this bracket. Now negative 1 over 8 times x will give you negative 1 over 8x, but please be careful. You have negative here, you have negative there, so that has to be positive. Then you you add 2 to both sides, so this is what you have, and then you simplify, and then we get this. You are done. Okay, so it's really simple. All that you have to do is to differentiate the curve, find a gradient at that point, then given the point you can find the y value, and you do substitution. You are good to go. Example 3. Right, so the curve has this equation, then there's a normal at the point P, 1, 4, and there's another normal at the point Q, 2, 5. Now these two normals are intersecting at the point R. Our job is to find the coordinates of R, right? So the thing is, you take point P, find the equation of the normal for point P, all right? Then you take point Q, find the equation of the normal for point Q. Then you solve the two equations simultaneously. The x and the y values will form the coordinates of R. So let's do that. Right, so let's differentiate this. Right, so we differentiate this. Now the differential of a constant is 0. Okay, so we differentiate only this part, and this is what we have. So we would start with point P. Okay, so at point P, the gradient will be the x value is what? Is 1. So we just put 1 there, and now you have what? 0. Right, now so when the gradient is 0, you might be a little bit scared at this point. You might think that you've made a mistake. My friend, you've not made a mistake. Everything is in order. Now when the gradient is 0, what it means is that it is horizontal. Okay, when the gradient is 0, it means that the curve that you are talking about, okay, it is 0. It is horizontal. So it's horizontal like this. Okay, that is why the gradient is 0. Now if the gradient is 0, that is, we have a horizontal case, then the equation of the normal, okay, it must meet it at what? At right angle, right? So the equation of the normal will be the x value, okay? the x value, because the y value is the 4, right? So it is horizontal like this, and then the x value will meet it. Okay, so whenever you differentiate a curve at a point and the answer is 0, then the equation of the normal is just the y value. So the normal is x is equal to 1. Okay, so the equation of the normal is x equals 1. All right, put that one in mind. Whenever the gradient is equal to 0, the equation of the normal is the x value. Okay, so x equals 1. Then let's go and take the second point, that is Q, and see what we can do with that one too. Right, so we have already differentiated it, so we will not differentiate again. And now this is Q. So let's go and look for the gradient at the point x equals 2. So at x equals 2, the gradient is 4. Okay, so now let's form the equation of the normal. But before that, let's put x equals 2 into the curve to look for the y value. Okay, so when we put 2 into the curve, the y value is 5. All right, so we put y minus y1, so y1 is 5. Then the gradient is negative 1 over m. But what is m? M is the gradient that we found, that is 4. Okay, into x minus x1. But what is x1? X1 is 2. Then we clean this up. All right, so we have y is equal to negative 1 over 4x plus 11 over 2. So now we have two equations. The first one was x is equal to 1, and now this is the second equation. So we are going to solve these two equations simultaneously, and then we'll look for x and y. Right. So like I said, remember that these normals intersect, hence we solve these two equations simultaneously. So we have this and that equation. Okay, so all that you have to do is to put the value of x into this equation and you are good to go. Right, so we put 1 in there, and then our answer is 21 over 4, or 5.25. Right, so we know the x value and now we know the y value. So the coordinate of r is 5.25. All right,